All right, got a big data exam coming up? You're in the right place. Think of this as your personal crash course. We're going to tackle the most common opening questions so you can walk in there totally prepared to nail the fundamentals right from the get go.
Okay, so here's our game plan for today. We're going to start with the basics. What even is big data? Then we'll decode those all important 5 V's. After that, we'll get into the core challenge, why distributed systems are the answer, the role of a data scientist, and finally, we'll walk through the entire data analytics process. Let's do this.
All right, first up, what is big data? We're tackling the most fundamental question of them all, the one that almost always kicks things off.
So here it is, the classic question. Explain the term big data and how you'd know if your organization has a big data problem. This is your chance to make a great first impression. Let's break down how to answer it perfectly, starting with that textbook definition that'll get you all the points.
Okay, so the official definition says that it's datasets beyond the ability of commonly used software tools. And you know what? That's the most important part. Big data isn't about hitting some specific number, like a terabyte. It's a moving target. It's the point where your normal tools just throw their hands up and say, nope, can't handle this anymore. So to put it simply, big data is stuff that's too big for your regular software. It's complex and moves fast, and it's a messy mix of things like clean databases and chaotic stuff like photos. And you mine it for clues to make better decisions. That's how you answer the second part of the question. You know you have a big data problem when your current systems just can't keep up. They're groaning under the weight of it all. Next up, let's decode the 5 V's. Seriously, you absolutely need to know these. If you get a question about defining big data, dropping the 5 V's is like an automatic point booster. It shows you really get it. Okay, V number 1, volume. This is the one everyone thinks of first. Just the sheer mind-boggling amount of data. We're talking terabytes, petabytes, zettabytes. It's just enormous. Think about it. Every single day, we create something like 2.5 times quintillion bytes of data. That's a number so big, it's hard to even imagine.
V number 2 is velocity, and this is all about speed. Data isn't just sitting there, it's flooding in at an incredible pace. Imagine trying to track every tweet during the World Cup, or every stock trade on Wall Street. That data is generated and has to be processed right now.
Third, we've got variety. This is a big one. Long gone are the days of nice, neat tables. Now data is, well, it's everything. It's structured stuff like you'd find in a database, but it's also your emails, your social media posts, videos, audio files. It's a wild, messy mix of formats. Number 4 is veracity. This one is all about trust. With all this data coming from everywhere, how do you know what's good and what's garbage? Veracity is about the quality and accuracy of the data. Can you actually rely on it to make a decision? It's a huge challenge. And last but not least, the 5th V, value. Honestly, this is the whole point. You can have all the data in the universe, but if you can't turn it into something useful, some real, tangible business outcome, then it's just digital noise. The goal is to find the value hidden in that massive pile of data. So that naturally leads to the next big question. Why are traditional databases failing? I mean, we've had databases for decades, right? What's so different now that they just can't handle the job anymore? Well, here's the core of the problem. Traditional databases are like building a house, but you have to have a complete blueprint before you even lay the foundation. Everything has a predefined place, a rigid schema. They're great if you know exactly what questions you're going to ask forever. But big data systems, they're more like a giant bin of clay. They're flexible, they can shape, and they let you discover things you never even planned for.
Okay, so if one giant, powerful computer isn't enough anymore, what do you do? The answer is surprisingly simple. You get a whole bunch of smaller, cheaper computers to work together as a team.
The analogy here is perfect. You wouldn't ask one person to build a skyscraper, right? Of course not. You get a huge team, and each person would work on the small part. That's exactly how a distributed system works. It takes a gigantic problem, chops it into tiny pieces, and gives each piece to a different computer to solve at the same time. And a perfect real-world example of this is the Google file system. Now, don't get bogged down by the diagram here. The concept is super simple. You've got one master computer that's like the project manager. It doesn't do the heavy lifting itself. It just keeps a map of where all the little data chunks are stored across hundreds of chunk servers. When you need something, you ask the master, and it tells you exactly which computer to go talk to. It's brilliant. But all this powerful technology is just a tool, right? You still need a skilled person to wield it.
And that brings us to the human expert behind the machine, the data scientist. This is another one of those questions you're almost guaranteed to see.
So what does a data scientist do? Well, they're part detective, part storyteller. They dive into all that raw, messy data and look for clues. They figure out how to pull in new information, run complex analyses, and most importantly, they're always searching for that hidden business value. They're the ones who connect the dots between the data and the dollar signs.
Okay, so what does that process actually look like? How do these data scientists take a giant, messy pile of data and actually find those incredible insights inside? It's not just magic. There's a method to the madness. And that brings us to our final section, the data analytics process. This is basically the step-by-step guide for finding that treasure in the data. You'll definitely want to know these steps. So it really breaks down into 4 main steps. Step 1, acquisition. You gotta get the data first, right? Collect it from all your sources. Step 2 is pre-processing. This is huge. You have to clean the data, fix all the errors, get it ready to use. Step 3 is integration. You bring all your different data sources together into one place. And finally, step 4, the fun part, analysis. This is where you actually search for the patterns and the insights that are going to make a difference. And this quote really says it all, doesn't it? The big justice we can do to big data is use it. That's the whole ballgame. Because what's the point of collecting all this information if you don't do something meaningful with it? It really brings everything we've talked about full circle.
And there you have it. You've now got the fundamentals down cold. You know what big data is, you know the 5 Vs, you know why old systems fail and how new ones work. So the only real question left is, what problem are you going to solve with all this?